Welcome to the Enigma lamp board build video. I'm going to show you all the stages of how to make this bare PCB into a fully functioning lamp board. This is one that I built into a nice case with the logo on the top there, available in my shop. And this project only has one big PCB, which makes things a lot simpler, but you do want to pay attention to whether things are being soldered on the top of the board or the bottom of the board, because it's a bit annoying to desolder them once they're already stuck in. You're going to want some basic tools, some side cutters for clipping off the legs of things, some pliers for doing fiddly stuff, and the screwdriver that came in a kit for the calibration stage, and a soldering iron and some solder. So we are going to start with the smallest components, the Schottky Diodes, the BAT42 diodes. There's 3 of these. The thing with diodes you have to pay attention to is they have to go round the correct way. You see on here there's a black stripe on one side. That black stripe needs to line up with the silkscreen stripe on the symbol, this way round. This one goes that way round, stripe to the stripe. Bend the legs over, plop it in, push it all the way down, and then solder it in. Lovely. And clip off the legs. Try not to get them in your eyes. There's your 3 diodes in and round the right way. Next are going in the resistors. You can tell the resistors because it's this shape silkscreen symbol and it says R. There's an R number and the value is in ohms, so either kilo ohms or ohms, just denoted by the R. 47 ohms, and this one's 47 kilo ohms. There's a silkscreen symbol guide in with all of the other documents for this module, so if you're unsure what anything is, you can check it out there. Okay, that's all the resistors soldered in. Let's now move on to the ceramic capacitors. You will find on the bill of materials, next to the value of the capacitor, there's also the code that is written on it, so you can tell which one is which. Now we're going to move on to the LEDs. LEDs are just a different type of diode, so just like the BAT42s earlier, you have to make sure these are going in the right way. So the long leg on the LED, that is the positive side, and that goes towards the plus symbol and the square pad. You will also notice that on the actual plastic bulby bit at the end, there is a flat side on the negative side. So if you've cut off the leg, you can still tell which side the negative and positive is. There are little square bits on the legs here, they're called stoppers, and when you put them into the pads, you just need to push a bit firmly to get those stoppers through, and then they live up to their name and stop the LEDs falling out. The simplest way to do this is just to put all of them in. The stoppers will not let them fall out, and then you can turn the board over, and because they're the tallest components we've soldered in so far, you'll be able to press down as you solder and get them flat to the board. All of these LEDs are labelled with the letter that they represent to the right side, except D30 down here, which is to the left of the 2N3906. And once you've got all of those in, you can have a look on the back and check that all of the long legs are pointed in the right direction, just to double check that you've got them round the right way, because trust me, you do not want to be trying to desolder these once they're in there. That will not be fun. And at this point, you've got a pretty nice sounding shaker. Okay, so now you can put it down, wiggle it around a bit, make sure everything's down. Just do one leg, then check it to make sure it's flat against the PCB, then do the next leg. Now we're going to solder in all of the IC sockets. Just be warned that the big wide ones go on the bottom of the board, and you want to make sure with these sockets that the little indent matches the indent in the silkscreen symbol. The IC sockets are soldered in. Let's move on to the 7805 voltage regulator. Now what you want to do is, where the legs get thinner, grab it with your pliers, bend them down 90 degrees, just like that. Then on the top of the board, it's going to go in here, pointing this way up. Now you want an air gap in between it and the board, so you need to put something in there to shim it up while you're soldering on the other side. I'm just going to use a breadboard buddy of mine, just put it under there. Anything kind of similar you can put in there, then put it down on top of it. Let's go solder these in. Do the middle leg first and just take your shim out. Got a little air gap there. Then we're going to put in the two transistors, the 2N3904 and 2N3906. You want to make sure not to mix these up. Very easy to do so. Now you'll see that the legs on here are pretty close to each other, and they're not going to go in very easily to the pads. So you want to bend them out a bit. So bend this one out, then the one on the other side, bend that out about to there. Then grab it with your pliers around about here and bend down. So they're a bit further spaced apart now, and same with the other side. And then you want to make sure that it goes in so that the flat side of it goes to the flat side of the silkscreen symbol. Press it in. Now we're moving on to the electrolytic capacitors. That's these suckers. These have got to go in the right way because they are polarized, and it's quite easy to tell which way is the correct way because you've got the long leg on the positive side, just like the LEDs, and just like the LEDs there is a positive symbol on the silkscreen. You've also got on the negative side this negative stripe, and if you look on the symbol there's also a little stripe down the negative side, so it goes in like that. You want to start with the shortest of the capacitors, just so it's not wobbling around. You'll know what I mean if you do it wrong. Just pushing this down as I'm soldering, make sure they're flat to the board. That's done. Now that they're all soldered in, we've got the sockets to go in. One here and the other. Let's make sure they're properly pressed down so that they're flush to the board. They are. So now you want to flip the board over to the bottom side, and you're going to solder in the power header. It goes in here. Push that down, that'll hold itself in place while you're soldering. Now that's soldered in, you want to put in all of the integrated circuits into all of their sockets. Make sure that the little semicircular indent at the top matches the semicircular indent on the socket and the silkscreen symbol. If the legs are not bent in enough, you can rest it on its side on a flat surface and just lever all the legs over so that it slots down nicely into the socket. Just evenly push it down, make sure it's seated in there nicely, flip it over. You need to decide whether you want alphabetical or ITA2 encoding. If you want alphabetical, put both the demultiplexers here. If you want ITA2, put them here. Don't mix and match them. Next, you're going to take two of these little M2 slotted screws, and you're going to turn the board to the bottom side and put them through these two little holes. There's one there and the other goes in here. It'll be a bit tight, just screw them down through the panel and they should hold themselves in there. Then turn it on over and take the two 10mm standoffs here, thread them onto those screws. Make sure that that is tight. Hold on to it one side, tighten it with your screwdriver the other side. Those are in there really solidly now. Next, you want to take this 20 turn trimmer, and this is a special one because the screw is on the side here instead of the top. That screw points outwards from the PCB and slots in here. Don't solder that in yet though, because next we are going to put the panel on like that. Slots over the jacks. Then you're going to take two more of these M2 slotted screws, and just like before, put them through the panel and into the other end of the standoff. Thread them in and make sure they are tight. Now you want to take the two hex nuts for the jack sockets, thread them on there, and you can just do them up with a little socket if you've got one, or turn them around with your pliers. Just do them really not too tight because you can easily over tighten them, just finger tight. And now it's looking pretty complete. You just got to do one more thing, solder in the trimmer here, and you can see why we left that, because it butts up right to the back of the panel, so you want to make sure that it's soldered right down onto the PCB. Okay, now we're ready to power it up, but just don't plug anything in to the input yet until you're prompted to during calibration. A little bit of information on the ribbon cables. You want to make sure that the red stripe on the power cable is going to where it says red on the PCB. So it's going to go on the header this way round, with the red stripe pointing down to -12 volts. And it's exactly the same with these rainbow ones. You can see the side that the red cable is on is going to be pointing downwards. Another way to tell where -12 volts is this little triangle on the plastic of the header. That means -12 volts. So you want to turn the module on and leave it to warm up for about 10 minutes, just because temperature does affect voltage levels and things like that. So you want to calibrate it while it's operating at a kind of normal temperature. In the meantime, what you can do is, with the screwdriver, turn this trimmer screw down anti-clockwise, and you want to go all the way down. You can tell it's all the way down because you will have turned 20 full turns. It's a 20 turn trimmer, or you'll be hearing a little click, and that will tell you that it's all the way down. So just turn it down. You can't damage it by turning it too far. So now I've got my 1 volt per octave scaled controller here. This is a Korg SQ1, and what we're going to do is send in 1 volt. So I'm going to set this sequence to 1 step. I'm going to set the range to 1 volt, and I'm going to turn this all the way up. And you want to do is take the CV out of that, put it into the CV in of the module, and you're going to turn the scale trimmer clockwise until the correct letter is illuminated. And if you've selected alphabetical mode, the correct letter at 1 volt should be L, and if you've selected ITA2 mode, the correct character will be N. I've got it in alphabetical mode. So now we're gonna turn this screw clockwise, and we shall see it go up in alphabetical order. Let's see, wait for the A to come on. There it is. If at this point you're turning up the screw on the trimmer and nothing is happening, well, we do have a little bit of a problem. So it's normally something very simple, so no need to panic at all. It's normally just a dodgy solder joint. So go carefully through the whole board and look at all the solder joints, check they're good. There's a great guide on Adafruit's website to tell you exactly what they should look like. The link to that is below. If you can't find anything there, look at all of the polarized components like the diodes, that includes the LEDs, the voltage regulator, the electrolytic capacitors, the ICs. They should have the little indent at the top matching the indent on the silk screen, and also the transistors, and make sure that you've got the right one in the right socket. There's A, and we're looking, because we're in alphabetical mode, for L. So B, C, D, E, F, G, H, I, J, K, L. There you are. Now what you're going to do is send in 2 volts. So that's 2 octaves up from middle C or from 0 volts. On my SQ1 I'm just going to change the limit here to 2 volts. So when this is turned all the way up, this is at 2 volts, and we should be seeing in alphabetical mode X, and in ITA2 mode you should be seeing O. So this is W, so you know you need to turn it up. That's clockwise. The scale, there is X, and then go back, check it with 1 volt, L, X. That's good, that's good. Now we know we're pretty close to where we should be. If you're scaling this in ITA2 mode, refer to the table in the build document and the user guide, and you'll see the sequence order for the letters. It's easy to tell in alphabetical, but not so obvious if you need to go up or down with the scale trimmer in ITA2 sequence. So now we're going to spend some time just going through every character and making sure that they're all right, and none of them are quickly oscillating between 2 characters, which will happen if you have the scale off and the voltage that you're sending in to the analog to digital converter is right in between where it's sensing these different characters. On my controller here, I'm just turning this pot up, so at 0 volts we've got no lamps illuminated, which is good. And then the next character, A, B, C, D, E. Oh, I've got this in linear mode, so I'm going to switch to chromatic, because then you know it's going to be exactly 1 volt per octave scaled. E, F, G, H, I, J. If you've got a keyboard, a piano keyboard that sends out CV, you can do this with the keys chromatically, and that would be an easier way to check. I don't have one in here, so O, U, R, S, T, U, V. Oh, and we've reached the limit of 2 volts. Let's go up to 5 volts. And once you've checked through all of the letters, you can keep going, and just they will repeat in sequence, and you can check that against the table in the build document and the user guide, and just make sure that there's no... Oh, here we go. See there you've got, I just touched the back of the PCB, that's why that's lighting up. You've got 2 letters illuminated. That's because the scaling is in between them, and now you need to work out which one it should be and then trim it either way. I'm not sure which it should be. I'm gonna go with U. I was right, because this is lining up very nicely. Oh, I'm gonna go down a little bit there. You can see here it's just wavering on the edge of the Y and the X, so you just want to do a really fine adjust just to bring that down, and keep checking everything. Make sure there's no wavering lights, and then once you're happy with that, the only thing left to do is to test the multiple output, the through output. So what you want to do is put in an oscillator, for example, and then you want to listen to it just to make sure that the signal is going through the module and out. This is the cable to our speaker. Put that in there and then turn up the pitch of the oscillator so you can hear it. That's working perfect. And that's everything done. I'm looking forward to seeing what people do with these. I've got loads of ideas myself, which is going to be exciting. You can build it into a nice enclosure like this. I made this out of oak, just like the original Enigma machines, and put the logo on there. Available in my shop. Okay, have fun.